Using the TI-83-84 Plus calculator for the sign test. This video uses example 2 from section 13-2 titled Flight Data. The TI-83-84 Plus calculator does not have a built-in function dedicated to the sign test, but it is easy to use the calculator's binom CDF function to find the p-value for a sign test. The binom CDF function uses the binomial probability distribution for finding the probability of x or fewer successes. Begin by using the sample data to assign positive and negative signs and discard any zeros. Let the test statistic x equal the count of the less frequent sign, and let n equal the number of positive and negative signs combined. In this example, we refer to Table 13-3 titled Taxi Out Times and Taxi In Times for American Airlines Flight 21. For this data, we find 8 positive signs, 3 negative signs, and 1 zero. Based on this, the test statistic x equals the count of the less frequent negative sign, which is 3, and n equals the number of positive and negative signs combined, which is 8 plus 3. Remember, we discard the 1 0 in this example. Open the DISTR or distribution menu on the TI-83-84 Plus calculator by pressing the second key, then the VARS key. Use the arrow keys to select the menu item binom CDF, which stands for Binomial Cumulative Density Function. Then press Enter. If using a TI-84 Plus C, enter the number of trials n found earlier. In this example, we enter 11. For p, always enter 0.5 for the sign test. For x value, enter the count of the less frequent sign found earlier. In this example, we found x to equal 3. Highlight Paste and press Enter. If you're using a TI-83-84 Plus calculator, with the binom CDF command on the screen, enter the following: number of trials, comma, 0.5, comma, count of the less frequent sign. In this example, we enter 11, comma, 0.5, comma, 3. Press Enter to display the result, which is the probability of getting x or fewer successes among n trials. Double this value for two-tailed tests. The final result is the p-value for the sign test. In this example, we are using a two-tailed test, so we double the result to get a p-value of 0.2265625. The p-value is greater than the significance level of 0.05, so we fail to reject the null hypothesis of no difference. In other words, we conclude that there is not sufficient evidence to warrant rejection of the claim of no difference between taxi out times and taxi in times. There does not appear to be a difference.